Hello, and welcome to Cost, Revenue, and Profit Models. My name is Tuesday Johnson, and this is an introduction to a concept with applications. Okay, so mathematical modeling. This is huge. This is what math is all about. From ancient Egypt through modern times, mathematics has been used to describe our world. It's the whole reason we developed it, and it keeps growing. To mathematically model a situation is the natural state of mathematics. And we have types of models, and we have kind of two models each. We have analytical models, and that's where we take a look at a situation and we create a mathematical model based on that. We also have curve-fitting models, where we fit equations to numerical real-world data. So on one, we might be looking at a situation, sketching something to go from that, maybe like a geometric model. Whereas if we have data as an output, we can find an equation to model it in curve-fitting models and possibly predict the future. It's what a lot of weather meteorology does. There's also continuous models where the domains, the inputs, are intervals of real numbers, as compared to discrete models, which are used frequently in probability and statistics. All right, so let's look at a cost function. A cost function specifies the cost C as a function of the number of items X. With cost, we consider both fixed costs and variable costs. A linear cost function has the form C of X equals mx plus b, and that's what we're going to use most of the time, where C of X is the cost of X items. Mx is the variable cost. Notice it has the variable with it. However, m, that slope, that's the marginal cost. All right, so m stands for marginal cost. And this has a big play in your next class if you have to take applied calculus. And finally, b is the fixed cost. So the cost of X items, the variable cost, the marginal cost, and the fixed cost. Not all cost functions are linear. So we will see some others. I can think of one that's a quadratic already. It's possible that cost functions are of any type of function, but I'm going to focus on the linear. Revenue and profit. Show me the money. The revenue resulting from one or more transactions is the total income received. A linear revenue function would be R of X equals MX. Notice there's no guarantee of a fixed revenue. We're not guaranteed to sell anything. We have to sell items to make money. So our variable revenue is MX, and our marginal revenue is just the M. Variable revenue has a variable with it. The profit is what remains of the revenue after subtracting our costs. So the profit is equal to revenue minus cost. PRC. Profit equals revenue minus cost. All right, so Math with Tuesday has merch. The design company, this is not true, but I'm working on it. The design company charges a flat rate of $170 plus $6.50 per shirt. If the shirts are available for $15 each, let's find the linear cost as a function of the number of shirts. Well, our fixed cost, let me find my pen again. Fixed cost, a flat rate of $170. All right, so that's our B value. The variable cost, well, that's right here. Per shirt, right? It changes depending on how many shirts I have. So the variable cost is $6.50 times the number of shirts. Right? The whole variable cost, it's not the variable is X. The number of shirts is X. So the variable cost will have the $6.50 per shirt multiplied by the number of shirts. And when we put this together, we'll have our cost function, 6.5x plus 170. This zero, not significant. It's not necessary. In terms of the problem, I would use 6.50. In terms of just straight up math, I'd use 6.5. Let's find the revenue as a function of the number of shirts. Well, the revenue, right, that's the money I make. I'm going to sell them for $15 each. $15 for every shirt, right? Variable cost includes the variable. So my revenue is simply 15x. And I hope I sell a shirt or more. Using the answers above, we could create the profit function, and we'll always want to simplify this. And so our profit is revenue minus cost. Revenue minus cost, so revenue is 15x, minus, anytime I'm subtracting, I'm going to follow that with parentheses so that I remember to distribute. All right, so I want to subtract the entire cost function using parentheses. So here I will have 15x minus 6.5x, which gives us 8.5x. And that 170 that was positive as a cost, well, that's negative in terms of profit, right? Because that works against us. So that's negative distributes to the 170. Cost, revenue, and profit functions. Let's start there. Same setup. Math with Tuesday has merged. Same everything. We know that the cost function is 6.5x plus 170. The revenue function is 15x. And the profit function is 8.5x minus 170. All right. When does cost equal revenue? That's a horrible question. How many shirts must we sell? I don't know what that is. For cost to equal revenue. Let me just rewrite that question that I don't know. I didn't catch it on the 14 times I reviewed this slide before I started recording. When does cost, how many shirts must we sell for cost to equal revenue? Well, we could put 6.5x plus 170 and set it equal to revenue. Let's subtract 6.5x from both sides. And from that, we'll end up with 170 equals 8.5x. Oh my goodness, look at that. That's the same numbers as we have over here in profit. And if we divide, oh no, I'm going to have to divide this in my head because I didn't have my calculator ready. It's totally my bad. Let's see if I can pull up a calculator real quick here. I know I should do this in my head, but it's pretty early in the morning and I want to make sure it's right for you. Yeah, I should have known that. 8 times 2 is 16. 2 times a half is 1. So that makes 17. So, and then the 0. Yeah, it makes sense. All right. How many shirts? We have to sell 20 shirts. Ooh, I might be able to do that. So what's the value of P of 20? And what is it? Oh, hold up. See how this problem started with words? Let's answer it with words. We need to sell 20 shirts for cost to equal revenue. I encourage you to use real words there instead of what I did. But so what's the value of P of 20 and what does it mean? Well, P, so that's our profit equation. The profit function is 8.5 times something minus 170. It doesn't matter where I am. I use skeletons. It could be an applied problem. It could be just a problem. Anytime I'm going to evaluate a function, I always use skeletons. So P of x equals 8.5x minus 170. I want to know P of 20. Sorry if you can hear my wheezing as I breathe in. I'll try not to do that into the microphone. 8.5 times 20, let me see. That's 170. 170 minus 170 is 0. So no profit or loss on 20 shirts. And that's exactly what we found here, right? In order for cost to equal revenue, I have to sell 20 shirts. What's the profit of 20? The profit of 20 is 0. It turns out that this break even, this is called break even, occurs when cost is equal to revenue or when the profit is 0. Okay, so if you're ever asked to find break even, you could use option 1 or option 2. Thank you for watching. Drop me a comment if you want me to get merch. I'm really thinking about it. I'm thinking that maybe if I just wore that on campus all the time, 1, I wouldn't have to think about what to wear every day, and 2, I'd be easy to identify. I appreciate you listening. Have a great day.